The other three trig functions, the cosecant, the secant, and the cotangent, of course, also have inverses, provided we limit the domain in such a way that makes those functions one-to-one. In a perfect world, we would fix the cosecant function the same way we fixed its reciprocal to find the sine function. Our world is almost perfect. It's not totally perfect, but it's pretty good. If I start at minus pi over 2 and go to plus pi over 2, I get a section of the cosecant function that's one-to-one. I hit every element of the range of the cosecant function one time and only one time. So I'd like to say the domain, I can limit the domain of the cosecant function to minus pi over 2 to plus pi over 2, except for, and we almost can, except for we do have to be aware of the fact that there's this asymptote, there's this place in the middle of that domain where the cosecant function isn't defined. So we have to say, okay, except for this 0 in the middle here, I can go from minus pi over 2 to plus pi over 2. As long as we're aware of that, that works. So minus pi over 2 to plus pi over 2, except for 0, same as the sine function. The range of the cosecant function is everything up to -1 and everything after +1, and that is, in fact, including -1. So I wanted a square bracket there, along with the other things that I erased. There we go. So for the inverse cosecant function, or the arc cosecant function, if you prefer, I can use a domain that is the range of the cosecant function, and a range that is the new improved domain of the cosecant function that we defined up above there, just minus pi over 2 to 0, and then 0 to plus pi over 2, so more or less, slightly less, the same as what we did for the sine function. And we're looking at, for the inverse cosecant function, quadrants 1 and 4 where it's defined. For the secant function, really similar to what happened with the cosecant, I'm going to be able to talk about, just like we did with the cosine, limit the domain to just 0 to pi, and just like the cosecant, I'm going to have to leave out this spot in the middle at pi over 2 where the secant function isn't defined. So if I limit the domain of the secant function to 0 to, we'll step over that asymptote at pi over 2, start up again on the other side and go to pi. That's really similar to what we did, 0 to pi for the cosine function. That's quadrants 1 and 2. The range is actually the same as the cosecant function. Infinity always gets round parentheses, of course, so I can do anything up to -1 and anything after +1. Then the domain and range for the inverse cosecant one, swap. As usually happens for inverse functions. And I'm looking at quadrants 1 and 2 for the range, making sure that we leave out that pi over 2 in the middle where the secant function isn't defined. For the inverse cotangent function, I would really like to say this has the same domain and range as the tangent function, the inverse tangent function, that I could limit the domain the same way. We could. It would work. If I go minus pi over 2 to plus pi over 2, That's fine. I hit every element of the range one time and only one time, if I write it carefully. And I would have to leave out this 0 in the middle where the cotangent function isn't defined. And that'll work, and we could do it that way, but we're not going to, because it's a little cleaner if we actually just recognize if I take one period, one complete period of the cotangent function, that's 1 to 1. So why should I fuss with having this asymptote through the middle when I could say, let's just take one complete period in between two asymptotes? So that's what we're going to do for the cotangent function. I'm going to limit its domain to just 0 to pi, not including the endpoints since I have asymptotes not defined at either end. The range of the cotangent function is all real numbers. So then for its inverse, since we've now defined a place where the cotangent function is 1 to 1, I can talk about its inverse. Domain and range swap, as usual. The domain for the inverse cotangent function is all real numbers, and its range is quadrants 1 and 2, same as the inverse secant function.